Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, I would like to introduce myself first. My name is Muhammad Arif Shamim bin Mazlan with metric numbers B0920100001. So, today I would like to explain about the basic logic gate. Let's go to the intro of this topic. Logic gate is an electronic circuit in which the inputs and outputs represent the statements of Boolean algebras. A logic gate will have one or more binary inputs of 0 or 1 but just one binary output. There are several examples of logic gates. Let's go through one by one. Firstly, the AND gate. It has two binary inputs and one binary output. The AND gate produces a true output. Why? If and only if both A and B are true. Otherwise, the output is false. AND gate will implement logical operator multiplication with corresponding truth table. Secondly is the OR gate. It has also two binary inputs and one binary output. The OR gate produces a true output if either A or B or both are true. OR gate will implement logical operator addition with corresponding truth table. Next is the NOT gate. It has only one binary input and one binary output. The NOT gate's output is the inverse of its output. If A is false, then Y is true. Vice versa to this statement. NOT gate will implement logical operator NOT with corresponding truth table. After that is the AND gate. It is the combination of AND and NOT gate. It will produce true output when any of the inputs are false, and it will produce false output when all of the inputs are true. Then, the AND OR gate. It is the combination of OR and NOT gate. It will produce true output when all of the inputs are false, and it will produce false output when any of the inputs are true. Furthermore, the XOR gate. A digital logic gate with two or more inputs and one output that performs exclusive disjunction. The output of an XOR gate is true only when exactly one of its inputs is true. If both of an XOR gate's inputs are false, or if both of its inputs are true, then the output of the XOR gate is false. If an XOR gate has more than two inputs, then its behavior depends on its implementation. In the vast majority of cases, an XOR gate will output true if an odd number of its input is true. Finally is the XNOR gate. A digital logic gate with two or more inputs and one output that perform logical equality. The output of an XNOR gate is true when all of its inputs are true, or when all of its inputs are false. If some of its inputs are true and others are false, then the output of the XNOR is false. So, next, my groupmate will construct a simple simulation to prove how the value of the input and output of the logic gate works in a circuit.
Assalamualaikum, my name is Nona Jiha binti Jusri Fauzi Menin with matric number B09201009C. I'm gonna do a simulation for part A. So I'm gonna do a simulation for IC type 7408 logic gate. So I'm gonna place the component of the IC type 7408 logic gate and place at the simulation circuit. Then I'm gonna place the VCC power source. And for the input, I'm gonna place the SPDT switch. For S1, it's going to be input A, and S2 switch is going to be input B. And for the output, I'm gonna choose for diode, which is LED blue light. Then I'm gonna place the ground. After I make sure all the component is here, then I'm gonna connect all the component to complete the circuit and run the simulation. So after I connect all this component, it should be like this. And after I make sure all the component is connected correctly, then I'm gonna run the simulation. So as I told before just now, the S1 is going to be input A and S2 switch is going to be input B, and the LED blue light is going to be output. For input, I have to switch off the turn off the switch for 0 input and turn on the switch for 1 input. Same goes to the LED. If the LED is turned on, so the output is 1. If the LED turned off, so the output is 0. So I'm gonna run a simulation for input 0 and 0. So the output for 7408 IC type logic gate is 0 because LED blue light is not turned on, it is turned off. So I'm gonna run for 1 input and 0 input. So the output is still 0 because the LED blue light is not turned on. Then finally I'm gonna do for 1 and 1 input. So the output is 1 because the LED blue light is turned on. So for example, I'm gonna change the component I want to do for 7432 IC type logic gate. I'm just gonna right click at the component and replace the component with the other component that I want. So for 7432, I'm just gonna click OK, and the IC type logic gate is changed directly, so I don't have to redo the circuit back again. So I'm gonna do this same step to do a simulation, and for 0 and 0 input, the output is 0, and for 1 input and 0 input, so the output is 1 because the LED blue light is turned on. So same thing goes for other component that I want to simulate to identify the type of the logic gate. So that's all. Thank you.
Based on the simulation part A made by Najha, I'm going to compare the simulation outcome with the truth table. So, since the simulation outcome, which is 7408 IC matches the truth table, then the 7408 IC is an AND gate. Assalamualaikum and good day. My name is Muhammad Irfan Daniel with matrix number B0920100077. Today I'm going to do the simulation for my part, which is part B. We're going to place all the logic gates and the components based on its position on the lab sheet. Firstly, we're going to pick a NOT gate. The first one, put it like this. The second one, put it like this. Next up, we're going to search for AND gate. This is this way, and then we're going to search for an OR gate. Place it like this, and the other one like this. After that, we're going to look up for a NAND gate. Put it like this, and the final one, we search out for NOR gate. We're going to take a logic converter and place it on the board. We're going to connect it accordingly to the lab sheet. Now the circuit is connected. We're going to pick a LED blue light diode, and next one is ground. Connect the LED and the ground to the circuit. The circuit is complete. Now double click on the logic converter and press the letter for the output, for the input, and press the button logic gate to the truth table to get the outcome. Based on the part B simulation, this is the Boolean expression. In conclusion, there is 7 types of logic gates, which is AND gate, NOT gate, OR gate, NOR gate, NAND gate, XNOR gate, and XOR gate. Each type of logic gates produces different output even though the value of the input is the same. Combination of logic gate is produced from combining basic logic gates. For example, NAND gate is the combination of AND gate and NOT gate. Next, Boolean expression is a logical statement that is either true or false. Boolean expression can compare data only of any type as long as the expression have the same basic data type. Normally, Boolean expression is used for combination of logic gates. Thank you.